thanks again, everyone who's joined us today to hear more about the how-to guide. As Hannah's mentioned, we have some of the authors of the guide here on the call today. So the very long titled guide, How-to Guide Applying the CIRIA SuDS Manual, sorry for the typo, C753, Simple Index Approach to Proprietary and Manufactured Stormwater Treatment Devices. So we're going to hear for most of the webinar from Daniel Jarman at Hydro International. He's going to go through the aims, the objectives, the purpose and use of the guide. So how the proprietary and manufactured stormwater treatment devices can can be used with the simple index approach and show some of the actual sort of workings out of the guide in that section. Then we're going to hear from Joe Bradley at Stormwater Shepherds on more of the practical applications of the guide, so how it can be used in relation to different types of SuDS structures, as well as the proprietary devices, followed by lots of time for a Q&A, and Daniel and Joe will stay for that. And we also have David Smoker joining us from ACCO. As Hannah's mentioned, there was another author to the guide, and we also had contribution from Mark Goodyear, formerly at Hydro International and now at Caerphilly County Borough Council. So we'd just like to thank him, and also our reviewers to ensure this was in line with the CIRIA SuDS manual, Bridget Woods-Ballard at HR Wallingford and Steve Wilson from the Environmental Protection Group, who were very generous with their time in helping us to review that. So thank you for that. Just before I hand over to Dan, a reminder where you can access the guide. So if you go to the British Water website, and if you go to the publications part, right now it's the big banner across the top because of the launch in terms of download and the webinar. But even once that's gone, it will be available in the publications section of the webinar. So if you haven't already downloaded it and have a look, do that. And Dan is going to help you make sense of all of the details in there. So I will stop sharing and pass you over to Dan, and I will speak to you again for the Q&A.
Oh, you're on mute, Dan.
It's a good start. Are the slides coming through? Thanks very much, and thanks, Jess. For those of you who don't know me, I'm Daniel Jarman, the Group Technical Manager for Hydro International. I've been working in the wastewater and stormwater sectors for about the last 15 years on the product development side and the product specification side. Obviously, Jess has introduced the webinar today, and we'll get onto the Q&A session. But the sort of summary, or in a nutshell, we've developed the document set here that plugs a couple of gaps in the SuDS manual to allow practitioners to use proprietary treatment systems with the simple index approach and effectively design them into SuDS treatment trains. The how-to guide itself provides a common basis for the evaluation and selection of SuDS components and brings manufactured treatment systems onto a level playing field with those already presented in the SuDS manual. So just what we'll cover today. The aim of the webinar isn't to get into too much detail in terms of the design process itself, but more cover the overall process that we've developed and where the documents are stored and how you go about the test process. So we're not going to get too much into the small print. If there's appetite for a separate technical session, sorry, I'm just noticing chats coming through. If there's appetite for a separate technical session, we can organise one following up after the Q&A event. So today we'll do a bit of an introduction to proprietary treatment systems, look at the contents of the British Water Code of Practice and the how-to guide. Jess has already covered where you can download these. A bit of a lead in through the SuDS manual and the simple index approach to set the scene. The process that you undertake for deriving mitigation indices for proprietary systems, the outputs of that process, essentially the documents and the proposed way of storing and presenting those. And then Joe will move on to a few design examples and we'll pick up with the Q&A session. So proprietary treatment systems, looking at the poll, most people already know from the cross-section of people on the call, but originally these were very heavily categorized as anything subsurfaced or piped systems. But there's more and more sort of hybrid systems and surface-based systems that blur the line between subsurface and surface zones. Typically, surface systems are favored, but of course, subsurface systems can be preferable where they allow additional design constraints to be met related to health and safety or space. And that also allows developments to meet targets related to other SuDS design objectives, such as amenity, biodiversity, and quantity control. Now, what you can see here on the slide is a handful of images related to proprietary systems. Depending on how you view the world, they get more complex the further down the slide you go. But broadly speaking, proprietary systems are harnessing the same processes that you would see in natural or green SuDS systems. And those are screening out of larger debris, settling out of dense particulate material, flotation of free phase oils or trash, filtration of the smaller or more neutrally buoyant particles, sorption of any dissolved pollutants like heavy metals or nutrients, and some of the more surface-based ones apply bioremediation and biotransformation. And that's where microorganisms or biological process can lock up the pollutants or transform them into a more stable form so they have a less damaging long-term impact. But generally speaking, the main focus is to capture the solids and sediments. Solids and sediments are either directly polluting and toxic or provide a very large surface area for other dissolved pollutants to bind to. So sediments generally carry the greatest pollutant load and pose the greatest environmental risk. Obviously, proprietary systems come in a number of different forms, from chambers, drainage channels, planter type systems, and that's to accept runoff and rainfall in a number of different ways. And so the question is, how can we apply these systems and make them fit with the requirements of the SuDS manual? And that leads us nicely into sort of a lead in through the SuDS manual, the SIA process, and the document set. So I keep saying the document set, and that's because the how-to guide has been introduced alongside the British Water Code of Practice for the assessment of manufactured treatment devices, which was launched back in 2016. You can see the covers of both of the documents on this slide and just mentioned where you can find them, but there is a link down at the bottom of the slide. The main issue we are addressing with both of these documents is arriving at a full set of pollution mitigation indexes or indices for use in the simple index approach. And we'll get into more detail as we go through the slide set. The first document, the COP, is a voluntary lab test protocol to generate supporting data for the derivation of mitigation indices for proprietary treatment devices. The tests in that code of practice are based on elements of the US New Jersey Department of Environmental Protection and German DIBT test protocols, but they've been adapted to make them relevant to UK conditions. We started out with the DIBT and NJDEP test protocols because they are well recognized, they're already scientifically justified, and there are already devices in the UK or marketed in the UK with these approvals. So we kind of have to recognize that these protocols are already present, but we needed also to reflect and adapt them to make them robust for the UK. We're launching the second document, which is the how-to guide today. This adds additional information to derive a full set of mitigation indices for manufactured systems. And that's because no single test process lets you arrive at a complete set of mitigation indices. It also presents the scientific justification behind the derivation process. Now, our original aspiration was to have a document that was sort of half a dozen pages and easily digestible. But once you start to look at all of the design questions and handling test data from these different protocols, we've actually ended up at a document at around 60 pages, and that covers a comparison of these prevalent test protocols, design examples for the selection and sizing of proprietary SuDS, derivation of the mitigation indices for proprietary systems, a comparison how they map up against field data, and how to map the mitigation indices that you've derived to a wider product range. And that's if there's different, range of unit sizes in a product range. So the main audience for this document set will be manufacturers undertaking and deriving SIA mitigation indices for their systems. And looking at the poll today, that seems to have attracted the right audience. But the how-to guide also contains sufficient information for, say, designers or local authorities and other approving bodies to understand and scrutinize the design processes and the selection processes for SuDS, including proprietary systems. So, most importantly, both of these documents, as just mentioned, have been reviewed by CIRIA and the authors of the SuDS manual to ensure that the approaches are, the design processes are in keeping with the SuDS manual and scientifically robust, and they have sort of the nod. So anything that is adopted from the SuDS manual into planning, these documents meet those requirements. So if all of that went, I would hope everyone is aware of what the SuDS manual is. I'm sure they are, but for those of you who are wondering what mitigation indices are and why you should care, we'll do a quick skip through the SuDS manual and the SIA, or the simple index approach design process. Of course, the SuDS manual is a very comprehensive guidance document published by CIRIA. The underpinning philosophy there is there are four main aspects or four pillars which are pivotal to the design of any SuDS scheme. And these are water quantity, water quality, amenity, and biodiversity. Of course, the SuDS manual contains many answers and has good supporting information where it's available. And although it's a guidance document, much of the design processes, or many of the design processes, have been adopted into local planning requirements. So you're seeing this guidance become mandatory. Now, the only downside, it's a bit of a doorstop of a document, so it's 1,000 pages long, and we are going to restrict our focus right down to design principles for water quality today, and then down again just to the simple index approach. And that lands us in chapter 26 of the SuDS manual, which is water quality design methods. Now, table 1, which is table 26.1, is reproduced on the left-hand side, and that covers the 4 different assessment methods of varying complexity that are valid in the SuDS manual. The complexity varies depending on the pollution hazards present and the sensitivity of the receiving water body. So the lower the environmental risk, the less complexity and the less effort is required in the design process. The first method on the list is the simple, or aptly named the simple index approach, the SIA method, and this is what the how-to guide relates to. So table 4.3, which is sort of 500 pages beforehand in chapter 4, actually gives guidance on where each of these design methods is applicable. And between these two tables, so table 26.1 and table 4.3 on the slide, you can determine which is the appropriate design method for your development. So for low to medium risk developments, the simple index approach is applicable with a couple of caveats. Examples of low hazard developments would be residential properties and low trafficked roads or car parks, such as schools and offices. Moving on to medium risk, you've got more highly trafficked zones such as commercial yards, hospitals, retail parks, and any other road that doesn't include trunk roads or motorways. So I mentioned a caveat in applying the SIA. For medium hazard sites that discharge to groundwater, the next complexity level up of the design process, the risk screening approach, must be applied to determine whether the SIA process is still appropriate. This is a risk assessment method mainly developed by highways that quantifies additional risk about the traffic levels and the risk to the groundwater. If it's still found to be a medium and low risk type of scenario, then you default back to the SIA method. An important point, the SIA method is not appropriate for high hazard scenarios. These would include trunk roads, motorways, and also industrial, chemical, fuel handling, waste management, and manufacturing sites. Now, I'll point out, due to the audience on the call, I noticed there are a number of interceptor manufacturers. SuDS devices are not oil interceptors. In the case of a high hazard site, designers would be referred to PPG3 to establish whether EN858 certified devices are required. Today, we are only interested in the medium to low risk sites, which are covered by the SIA method and expected to sort of cover that method is expected to apply to the vast majority of SuDS design cases. So jumping into the SIA process itself, I appreciate this is a bit of a busy slide, but it's kind of the minimum content. You need to give a bit of a crash course in the SIA process. So bear with me and I'll talk you through it. The SIA design process is a source pathway receptor approach. It quantifies the hazard a particular site or source presents and requires that the pollutant pathway present mechanisms to get your hazard level down to an acceptable level before it reaches the receiving water body, which is the receptor. Now, in the SIA process, 3 pollutants are essentially analyzed, which are TSS, heavy metals, and hydrocarbons. A value named the pollutant mitigation index is used to select SuDS components that reduce hazards to an acceptable level. So I've run through a quick example of this. Step 1 is to allocate sorry, I'm aware there's text coming up. We'll come to the questions at the end. So step 1 is to allocate a suitable pollution hazard index for the proposed land use. If we take, say, a typical residential development, which is considered low risk, you get pollution hazard indices of 0.5, 0.4, and 0.4 for TSS metals and hydrocarbons, respectively. You then move on to step 2, which is to select an appropriate mitigation index that meets or exceeds that hazard value. The mitigation indices are contained in table 26.3, and from the requirement of 0.5, 0.4, 0.4, there's a number of SuDS systems or SuDS components that can address that hazard level. However, a filter strip or swale would be sufficient in this case. The only point to note here is that if you have a hazard or if your mitigation indices or a single device cannot meet your hazard level or bring it down to an acceptable level, you can chain SuDS components together and sum up the mitigation indices. However, the downstream components, the mitigation indices, are multiplied by a factor of 0.5. So that device or anything downstream is assumed to be half as effective as the first treatment component. And that's to account for a lower concentration of pollutants entering those downstream SuDS components. And step 3 is to apply a more precautionary approach if there is a sensitive or protected water body downstream. Now, this is a bit of a catch-all because it's there to address the fact that the SIA methods makes broad assumptions about the receiving water body sensitivity, but that's fine for low to medium risk scenarios. Having been through a bit of a crash course in the SIA method, the difficulty for manufacturers and proprietary systems is that table 26.3 contains mitigation indices for green or natural systems, but it does not contain any mitigation indices for manufactured systems. So this is the gap that we have bridged with the COP and the how-to guide. I'll quickly just touch on where those mitigation indices for the green or natural systems come from, because it's relevant to understanding what we're trying to achieve for the proprietary systems. So the mitigation indices are an indicator of average annual load reduction of a particular pollutant. They've been derived from a project called the USBMP database, or the Best Management Practice database, and that's recently been retitled the International Stormwater BMP database. This project monitored over 700 different sites throughout the US to establish the efficiency of different SuDS components. A summary of the findings is presented in table 26.13 in the SuDS manual, which is kind of hidden away in an appendix. But we don't need to go into this in too much detail, but I'll quickly give an example of how it maps over to the mitigation indices. So if you take a detention basin as an example from the BMP database, you've got an interquartile range for TSS at the inlet and outlet of, well, at the inlet it's 20 to 114 milligrams a litre, and at the outlet it's 10 to 47 milligrams a litre. So you're getting around about a 50% reduction in the pollutant load. And you see that reflected in the mitigation index, which is 0.5. So I hope that gives a bit of traceability to where those numbers come from. It's based on an annual performance rating. So manufactured systems were actually included in the US BMP project, and it aimed to categorize them by general treatment approaches they applied. However, mechanisms that manufacturers apply are quite specific, and sort of arrangements of internal bypasses and baffles means that it couldn't be generalized. So due to this, the SuDS manual has set out a requirement that the mitigation indices must be declared by the manufacturers. And jumping to take a more detailed look at that requirement, at the end of table 26.3, it lays out the requirements for proprietary treatment systems, which is they must demonstrate they can address each of the contaminant types to acceptable levels for frequent events up to approximately the 1 in 1 year return period event for inflow concentrations relevant to the contributing drainage area, which is a bit of a mouthful, but what it's essentially putting the responsibility on the manufacturers for is to quantify and demonstrate the annual pollutant inflow and removal rates for TSS, heavy metals, and hydrocarbons, and that's under treatment flow rates up to the 1 in 1 year event. Now, broadly speaking, this gives mitigation indices that are equivalent to those presented and derived from the US BMP database. The British Water Group has been working towards a standardized and robust approach for the derivation, the testing and derivation of mitigation indices that is in accordance with this requirement of the SuDS manual. And this is what we've arrived at with the COP and how-to guide. So just moving into the COP test processes, to quantify the pollutant removal rates, essentially what we're doing is putting a known amount of pollutant into an inlet under controlled conditions and measuring the outlet concentrations using the setup shown on the slide. TSS retention is tested at full scale, and the dissolved metals retention is tested at down to a 1% scale sample of the filter media. Now, the reason that the dissolved metals isn't tested at full scale is because we're trying to avoid labs having to deal with a large amount of contaminated water and disposal of that. Hydrocarbons is not covered in the code of practice. As I mentioned before, if there's a significant risk of hydrocarbon spill, designers should be referring to PPG3 and using EN 858 certified systems. However, for the low and medium risk scenarios that SIA is appropriate for, there is information in the how-to guide to derive mitigation indices. What you can see from the test setups is, despite the scale, the testing looks relatively familiar. We're controlling the flow rates and inflow concentrations, and we're measuring the output concentrations to determine the pollutant load reduction. Now, I mentioned we're controlling the flow rates. Of course, flow rate is one of the most detailed aspects where we've placed effort in developing the code of practice and the how-to guide, because it dictates the size and obviously the cost of the system. Broadly speaking, pollutants and sediments or sediment distributions don't vary much between Western cities with temperate climates. What does vary is the rainfall distributions. So we've had to do a bit of analysis there to make sure that the design protocols and the test flow rates are representative for the UK. So we took EA rain gauge data from 7 cities and processed that to determine rainfall volume contributions related to rainfall intensity. And what we found is, while there's a little bit of variation, you can use a single set of flow rates for the design and for the testing. And there's very, very little difference in the peak annual flow rate across England. This analysis was carried out by HR Wallingford and Cranfield University. As manufacturers and designers, the number we're most interested in is that sort of peak treatment flow rate, or the treatment flow rate the device must be able to handle, because that dictates more or less the overall size and cost of the system. In this case, the magic number is 27 millimeters an hour in terms of rainfall, because that accounts for 99% of all rainfall volume. When you map this over to a runoff rate, you get 75 litres a second per hectare. So that is to state that if you have an impermeable area of 1 hectare, you need a treatment device that's going to be able to treat 75 litres per second to the stated mitigation indices. The only caveat here is that the system must also be able to safely pass a 1 in 30 year 15-minute event. This is a requirement laid out in the SuDS manual and DCG. This is not a tested flow rate, it's a hydraulic requirement. So you're not looking at treatment capability at this flow, but it dictates whether the system can be placed online or offline for that 1 in 30 year event. So moving on, how the test data feeds into the how-to guide. Now, the how-to guide gives procedures for determining mitigation indices from multiple recognized SuDS assessment protocols. So it can accept data from the British Water Code of Practice, the New Jersey test protocol, and the DIBT test protocols, but none of the tests give you a complete set of mitigation indices, which is a little bit unfortunate. The how-to guide fills that gap by giving the procedures for deriving the missing components. So taking the route of the Code of Practice as an example, the Code of Practice only covers testing for quantifying annual load reduction of TSS and dissolved heavy metals. Hydrocarbons and the solid phase of heavy metals is not tested. So the how-to guide then explains how to populate these values to arrive at a full set of mitigation indices, so you can design for those low or medium risk sites. Now, there's no pass or fail in the process. It allows manufacturers to essentially declare and design to any mitigation index or indices they deem fit. And that gives a great deal of flexibility to both designers and manufacturers in this process. So the outputs of that process are 3 documents. The first is a test report, either from the British Water Code of Practice or New Jersey or DIBT. And this will obviously be signed off by the test house that performed the testing. So you've got some quality control and reassurance there, but that's only for a single unit size. You only test 1 device. So the second document is a declaration by the manufacturer of their SIA mitigation indices. And that is derived from the how-to guide, and also then how those mitigation indices are mapped to different unit sizes and the flow capacities that can be handled by various sizes in a product range. And the third document we're recommending is an independent verification statement. And effectively, this is a desk check to ensure the mitigation mitigation indices and flow rates have been derived correctly from the test data and the how-to guide. Now, this should be signed off essentially by an independent consultant or appropriate approver in the field. We've taken this route with British Water because they are not a certifier and they're not a regulator, so there's no real certification process here. But of course, completion of this set of documents will allow manufacturers to demonstrate that their published mitigation indices are appropriately evidenced and derived in accordance with the requirements of the SuDS manual. And of course, that immediately maps over to any planning constraints that have made it from the SuDS manual into local planning requirements. So British Water are in the process of setting up a website to house these output documents. This is purely going to be a repository for supporting information for manufacturers to upload and designers to essentially view the documents. You don't need to be a British Water member to use this site. Obviously, you can see the headings for the columns there, but the last 3 columns are those documents that we talked about on the previous slide. So the test report, the declaration of the indices, and the independent verification letter. And then finally, we've also set up a clarification site. I mean, in the acknowledgement that no test process or guidance is perfect, what we're intending to do as questions come through or addressed to the group, we'll make sure those are fully transparent. Any conclusions or loopholes are addressed, and we document them here. As we populate the site, it will give a reason to revise and update the documents at a later date. So far, there's been a couple of questions related to sand grades and sample containers, but nothing that dramatic. And with that, I will hand over to Joe for a few design examples.
Thanks, Dan. Can you stop sharing and then I shall?
I'm just trying to find the button. There we go.
Pick up the gauntlet.
There we go.
Thank you very much.
Just while you're getting that set up, Joe, just a reminder, you can pop questions in the chat field now and we will collate them all, excuse me, and come back to the Q&A at the end. Alternatively, if you want to ask them yourself when we get to the Q&A section, you can pop your hand up.
Thanks, Jess. Can you see my slide okay?
We can.
Excellent. So I'm going to do just 5-10 minutes on using the mitigation indices that you derive from going through the process Dan has just described. So you will go through that process and you will end up with a set of mitigation indices for your stormwater treatment product. Hold on, the slides are blowing up. That's it. Big shout out for the SuDS manual. Don't forget that this whole process sits within the sort of umbrella of the SuDS manual. And you must remember, as you drift into using manufactured products as part of your SuDS management train, you must also remember that these things are essential: the master planning, the maximisation of use of surface features, and interception. So don't be distracted. Don't disappear down a manufactured device wormhole, as I often do, and forget about the primary principles of the SuDS manual. So just a couple of examples of how we use mitigation indices and hazard indices in order to do the simple index approach. This is a swale in Chorley. It's become famous because I use pictures of it all the time. And you'll see on that little chart in the left-hand column the mitigation indices for a swale that are provided in table 26.3 of the SuDS manual. So you've got those, you know how much treatment and mitigation that swale can offer. So is it good enough for low and medium risk sites? So in the next column, you've got the pollution hazard indices for a low risk site, 0.5, 0.4, 0.4. And you can see that a swale on its own is adequate to deliver the pollution treatment that you need for that low risk site. For a medium risk site, however, with a pollution hazard index of 0.7, 0.6, 0.7, that swale on its own isn't good enough. And so you'd start to need to design a SuDS management train, either including that swale or trying to choose different solutions. Same process for a pond. The mitigation indices from table 26.3 for a pond are 0.7, 0.7, 0.5. And so for a low risk site where you've got those pollution hazard indices, that pond on its own offers enough water quality treatment. For a medium risk site, however, there's a gap, and you would need to address that gap by introducing more treatment for hydrocarbons. However, the SuDS manual says that all ponds should have a sediment capture device upstream. So if you design your SuDS management train well with a sediment capture device and a pond, you can satisfy the requirements of the simple index approach very easily. For a vortex grit separator, this is a manufactured treatment device. So we're going to start looking now at what we're talking about more specifically this morning. The mitigation indices are provided by the manufacturer, as we've just described, and Dan's just gone through the process. So the mitigation indices in that first column might be given to you by the manufacturer as 0.5, 0.5, 0.7. So again, for a low risk site, those pollution mitigation indices are adequate to satisfy the simple index approach. And so you could just install that vortex grit separator and it will deliver all your water quality treatment requirements for that SuDS management train. For a medium risk site, however, it doesn't satisfy the requirements of TSS and metals. So again, you'd have to incorporate it as part of a SuDS management train. So you ask the manufacturer to provide the mitigation indices. You check on the British Water website going forward to make sure that those mitigation indices are on the British Water website and you know that they have been derived properly. And then you can comfortably and confidently use these devices as part of your SuDS management train. Remember though, and this is what I'm saying about not disappearing down a manufactured device wormhole. That seems simple, doesn't it? That device delivers all your water quality treatment requirements for a low risk site in accordance with the simple index approach. But you must also deliver the other benefits of a SuDS management train. So the water must then go on into a vegetative device to deliver amenity, biodiversity, and obviously the hydraulic control for the water off site. So you need to incorporate these devices as part of a SuDS management train. This is a famous and long-standing illustration of a SuDS management train that I like. So this is a vortex grit separator feeding into a pond. So you take the mitigation indices of your vortex grit separator from the manufacturer, and then you have half the mitigation indices of the pond, as Dan described earlier, and that you work that out as your SuDS management train and decide if that satisfies the pollution hazard indices for your site. Now, for a low-risk site, that's perfect. You're delivering sediment control, pollution control, attenuation, biodiversity and amenity. That's a very sensible solution. But for a high-risk site, there's more detail to work out before you can go forward. The most important thing to think about is treatment flow rates. And this keeps me awake at night and has done for some years. All the devices, vegetative devices and manufactured devices, have a treatment flow rate, so the amount of water they can treat in a period of time, and a hydraulic flow rate, so the amount of water they can convey forward as a maximum capability. And the two things are usually different. So usually a device will treat a certain volume of water or a certain flow rate, but it will convey more water or a greater flow rate. And you need to understand the difference between those two in your design and make sure you are delivering enough treatment flow rate, enough treatment for your flow rate. So a pond, for example, might be able to cope with really high flows in a major rain event, but you need to understand what your treatment volume of your pond is using the calculation in the SuDS manual and check that you have enough treatment volume as well as enough hydraulic volume. And I see quite a lot of end of pipe ponds that make me wince a bit, because although the calculations for the hydraulics have been worked out, I'm not convinced that there's enough time for the water to rest in that pond, for sedimentations to take place, for the plants to have the opportunity to take up nutrients, for the sunshine to have the opportunity to break down that organic pollutants. So you need to understand, what are you asking that pond to do, and is it big enough? And those are the calculations that are important. The stormwater filter can tolerate high flows through it. It'll have a bypass mechanism, but you need to understand what flow rate is being treated. And in a stormwater filter, the treatment flow rate is usually quite low, but that's okay because the treatment capability is very high. So you might only treat a little bit of the flow, but you treat it very well. And also it's really important to understand the flow rate off your site. So you need to do the calculations, perhaps using a modelling package, to understand how much water you're going to get off your site, how much water can be infiltrated safely without causing groundwater pollution, and what your treatment capacity is that you need. So the simple index approach is simple, clues in the name, but you need to also understand the relationship between the hydraulic calculations and the treatment calculations. So how much storm must you treat? Dan's already told us that we need to treat 75 litres per second per hectare, depending on the runoff coefficient. And that's a 1 in 1 year, 15-minute storm event. And if you treat that, that's most of the pollution load coming off that catchment in a year. But a few times a year, more so in Lancashire perhaps, it rains harder than that. And you need to understand what you're going to do with that excess water. Are you going to treat it? Are you going to convey it through your device? Are you going to attenuate it, or are you going to bypass it? And you need to work out what decision you make there and what impact that will have on your treatment. Very important for some of the pollutants. So phosphates get washed out easily. So if you've got a pond for phosphate treatment and you put a whooshy flow through for a 1 in 30 storm event, you may take all the phosphate with you and you've negated any benefit. So understand your pollutants, understand your pollutant capture processes, and understand the impact of flow on those. As I mentioned a minute ago, some treatment devices work really, really well. So some of the filters can catch above 90% of the metals that they're capturing. And so you only need to treat a small part of the flow in order to reduce the pollutant load. So if you remember Dan's graph of the rainfall events up to 10 millimetres is a huge proportion of the rainfall events in the UK in any 1 year. So if you treat that to a very high standard, that may reduce the annual load of pollutant enough that that does what you need it to do to protect the environment. So we're starting to talk now about bypassing and also blending. So treating some water incredibly well and then blending it back with the rest of the stormwater to deliver a pollutant load reduction. So these calculations are starting to be more complex and perhaps apply to high risk surfaces as well. So the British Water Code of Practice, so the test protocol that Dan described earlier, describes how you must treat the 1 in 1 year storm event, 27 millimetres per hour. But you must also check in your test protocol that if you put 40 millimetres per hour through your device, you don't whoosh all the pollutant out. And you also need to understand if your device can safely convey a 1 in 30 rainfall event, so 90 millimetres per hour, or if that flow will have to be bypassed around the device. A couple of examples here. Please don't bite my head off. These numbers are not explicitly applicable to these devices that I've illustrated. I've just used them for illustrative purposes. But these are some ideas of what you might consider for a treatment train, particularly for maybe a high-risk surface. So you might start with a vortex grit separator. And again, I've indicated here that these are sized. So there is a full range of sizes of these devices. And so the flow rates I've illustrated may represent just one size. A lot of them go a lot bigger than this. So your vortex grit separator might deliver 0.5 TSS, 0.5 metals, and 0.7 hydrocarbons for your mitigation indices. It might tolerate 91 litres per second as a treatment flow rate, and it may convey all your flow forward through the internal bypass mechanism. Downstream of that, you may have a stormwater filter because you may have a particular problem with dissolved metals, for example, and that will give you a mitigation indices of 0.8 for TSS, 0.8 for metals, and 0.7 for hydrocarbons. But you can only use half of those mitigation indices because it's a downstream device. Now, you may have put there that the treatment flow rate may be good, so it may be 85 litres per second, depending on what size device you select, and it may be able to convey all the flow through it. But just ask yourself if the filter is going to be okay with that massive flow through, or whether you might want to consider putting it offline. Kind of depends on the choice of filter that you make. And then if you bypass that filter, so if you just put your 85 litres per second through the filter and bypass all other flows around the filter, you can blend that water back together and put it in your pond. And then your pond delivers 0.7, can't see, 0.5, 0.7, 0.7. And again, you only get half of those scores because you're a downstream device. So you can see how we're starting to design SuDS management trains using a combination of manufactured treatment devices and vegetative treatment devices. And you need to understand how much flow you can put through those devices and get sensible treatment. A couple of other examples, and again, numbers for illustration only. You might choose, if you've got an oil spill risk on site, so if your site is a high risk site with an oil spill risk, or indeed a medium risk site with an oil spill risk, you may either want to or have to put in an oil water separator, and this is a bypass oil water separator. So it might treat 15 litres per second for a little sized one, it gives you good mitigation indices of 0.8, 0.6, 0.9. And then downstream, you might have something like a modular bioremediation zone. And these are cool because they only take quite a small flow rate, so treatment flow rate of 10 litres per second per unit, but you can have lots of units distributed across maybe a residential development or a commercial development, which is representative of the source control SuDS that the SuDS manual prefers. So you break your catchment down into smaller catchments and have devices for each of the smaller catchments. And then for high-risk surfaces, which is where I spend most of my time working, please remember that it's not just the simple index approach. You must do a full risk assessment for your development. You can incorporate the simple index approach into it to do those calculations we've just described. That's fine, but you must also think about spillage risk. Do you need a bypass oil water separator or a full retention oil water separator or some other spillage risk, spillage control mechanism? Fire water risk, what happens if your factory burns down? Where does all the fire water go? Do you have chemicals on site? Do you need closure devices on your SuDS management train in order to shut the whole thing down if there's a fire? Or do you need specialist filters? So there are loads of filters on the market that deal with pesticides, for example, specialist pollutants. So those calculations I described earlier, where you're looking at flow rates, conveyance rates, attenuation rates, and blending, they all become more important when you're looking at high-risk sites. Please remember groundwater protection. I do try and say that as often as I can. It's really, really important. Where you put them matters. If you've got a sediment removal device, it needs to be at the top of the catchment because the sediment will settle out as soon as it can. So as soon as your water rests, the sediments settle out. So put that at the top of your catchment because then your downstream devices can work better. Filters usually downstream because they need the sediment to be gone first or they get blocked. So sediment device and then a filter. And obviously spillage containment devices, so separators, closure devices, you need to put them in the right place so that they will capture the spillage and also control any discharge off site in the event of an emergency. And last but not least, maintenance, maintenance, maintenance. Don't put all these beautiful devices into your SuDS management train and then not maintain them. This is a, thanks to Paddy, I think, who's on the call for this photograph, this is an oil water separator that has effectively captured that nasty, gungy, toxic sediment, which is what it's designed to do, but you must empty it or it stops working after 5-10 years. The same with all devices. They all have a period of time in which they'll work and then they stop working. You must maintain them. And that's me. Thank you very much.
Thanks very much for that, Jo, and thanks, Dan, as well, for your presentation and dive into some of the more technical details. So we've got a few questions already in the chat. I'll start with those. Dan and David, if you're ready to pop your videos back on. So the first question we've got coming is from Elliot Evans. Elliot, I'm not sure your company, but you've asked, we're seeing oil separators being tested to DIBT and the code of practice with very good mitigation indices. Are these type of systems recognised for SuDS designs? I think you've touched on that a little bit, Jo, in the practical application, but is there anything else you want to add there?
Only to say yes. So any of the devices that are tested in accordance with one of the test protocols and then the mitigation indices are derived in accordance with the how-to guide, then that component can be part of a SuDS management train. Remember that you're delivering all 4 pillars of SuDS with your SuDS management train. So for an oil water separator, for example, brilliant for spillage control, brilliant for sediment removal, but you then need to deliver something for vegetation amenity and obviously your hydraulic controls as well. So yes is the answer as part of a SuDS management train.
Yeah, I think you need to differentiate between where it's full retention separator or separator where it's, for example, on the filling station where its function is to prevent any hydrocarbons going through, and where you're using it as a general separator which removes sediment, removes hydrocarbons and so on, where it can be used as part of the SuDS train.
Thanks both for that. I think yeah, it's a really good point that the intention is to be complementary and not to, you know, be replacements necessarily for other SuDS systems. So a question on operation and maintenance. I think that was a good photo at the end showing a full oil separator there. Peter Coombs from Innovise has asked a question about two questions actually. So I'll start with the operation and maintenance one as we were discussing that. Who is maintaining these devices, and who would be expected to monitor that in the long term?
Oh, that question.
Well, yeah.
Because the answer is it's not very good in the UK. They are often operated and maintained by the site owner if it's a high risk surface, or the developer, or the local authority, or the water company, depending on who adopted them. Long-term maintenance and operation is poor in this country. We don't have a system by which that's enforced, and it should be. So if I had my way, your SuDS management train would be detailed in your drainage design application for your planning application, and that would be embedded into your section 106 agreement with the adopting authority, and then it would be enforceable. However, there's no enforcement officers because there's no money, but at least we'd be halfway there.
Yeah, I mean, this subject is out of the scope of the two documents, but yeah, it's a difficult issue at the moment in terms of even on vegetated SuDS components. Are they being maintained properly? Usually not. Maintenance is not at the right frequency, or it's not of the right type, or whatever. So it comes back to what Joe was just saying. It's really important to get that the maintenance as part of the design application, so that it is then handed over to whoever's adopting it, and then takes the responsibility for maintenance on an ongoing basis.
No, it doesn't help the UK, but I believe that's the way it's structured in Germany under the DIBT protocol, absolutely. That with the installation and the planning consent, there has to be a number of years of maintenance contract implemented. Right. But also, actually, as a manufacturer, you lose sight of the maintenance because you don't always end up with you're interacting with designers and consultants, but you might not actually ever see the final owner.
Also, the good people of Germany all pay an amount of money into a central fund for stormwater management, which is what we also need, but it's not happening. When I'm Prime Minister, then I'll
We'll all look forward to that, Joe.
Yeah. Parties in number 10 with your Prime Minister.
I was going to say, isn't the Sue Great report coming out today? You might be have a show
with a shout. Yeah.
Okay. So Dan, maybe you can take this one initially from Peter Coombs's first question on the approving authorities checking the simple index approach on each development and whether they're suitably confident or competent, and a need for training. Perhaps you can speak to how you might expect an approving authority to interact with the guide, presumably not following through an example in every step to the great levels of detail.
I would almost decouple this from green or proprietary systems entirely and just say the process should work, that there's a planning consent, and of course it goes to a lead local flood authority, and it's, in fact, Mark might even be, sorry, I know Mark's on the call probably, but yes, whether that happens and how competent, there's very little sight. Obviously that approved plan comes back through the designers to a manufacturer. I don't know if David can speak a little bit more about that.
No, I think you're absolutely right that it's the designer and their relative level of competence or confidence in terms of looking at the simple index approach and making sure that the mitigation indices used for each component, whether it's vegetated or whether it's a manufactured component, actually meet the requirements of the simple index approach. And they should also be doing the checking in terms of whether it's low, medium, high risk, etc. So whether they can use a simple index approach or whether they need to go for a more risk-based approach. So yeah,
I think
that's the way it should happen anyway.
It is a highly technical subject once we include all of the different water quality design methods.
That's the difficulty, I think, the hydraulics. the methodology for checking the hydraulic calculations is quite straightforward and it's widely available, but understanding the water quality and indeed the biodiversity is tricky. And a lot of local authorities haven't got that expertise. It's better in Wales because the SABs are building up that expertise and some of them have already got it in with knobs on. But in England, it's not good at all. And that's because the local authorities haven't got the resources.
Yep.
I think as Dan mentioned, the intention is that if those documents, if the code of practice is followed, if the process in the how-to guide is followed and then independently verified, whilst British Water isn't in a position to do that verification, if an independent verification certificate has been obtained and shared with British Water, that will be available on the British Water website. So the idea is at least to provide some transparency there in terms of those manufacturers that have been through the process and had somebody else look at that derivation, such that I think a local authority doesn't necessarily have to repeat that process. Okay, so there's a question as well, more coming back to the testing protocols themselves. So there's the code of practice DIBT, NJDEP, mentioned as robust testing methods, and some products that have been tested following Austrian standard testing protocols. Would they need to be retested, or could it be shown that the testing already completed is robust enough? I'm not sure if that's a question for this call necessarily. Does anyone want to?
I can probably speak to that. I'm not familiar with the Austrian protocols, but if there is sufficient information in the test report that can be mapped over to the main change is mapping it over to the UK flow rates and looking at what volume of rain falls at a given intensity. So provided there is sufficient information in the report, no, the devices wouldn't need to be retested. And that was part of the sort of the motivation here, to not have to retest everything, but provide some recognition that there are well-acknowledged standards already out there in the market.
Yeah. And within the how-to guide, there's a methodology for actually how you convert from flow rates used in other test protocols to the UK test protocol. So again, as Dan says, if there's enough information that mapping can be done, then I think we'd probably say, yeah, that's robust enough, and we could work through to the mitigation indices.
Because the examples of the interpolation to the UK flow rates is included in the how-to guide. We haven't done it for the Austrian protocol, but there's no reason we couldn't work through that.
Okay, thanks for that. I'm sure that's helpful. So we've got some comments, I think, next, rather than a question, from a local authority engineer, saying they're very constrained budget-wise for maintenance. And as such, many of these more innovative treatment devices that are proposed are resisted by the asset team, or if accepted, not maintained well, coming back to that point we've discussed a bit. And that part of their job is to help educate such teams to improve their knowledge as they sit along as a consultant alongside the LLFA Highways Authority asset team. As designers, they're keen to promote and use such devices and are actively using the simple index approach for planning. So as a writer of technical guidance HCC, I think that is, I can't quite see the full name in the chat, but presumably that's a county council. They're promoting this methodology for design and welcome the additional guidance for proprietary products. So it's good to know that after the years working on the guide, it is potentially going to, help where there's been a gap before. So a question.
Sorry, just with regard to maintenance, and yes, in some respects, these proprietary treatment devices will require maintenance at a defined period or whatever. But in but also vegetated systems will also require maintenance because they will block up and so on and so forth. The thing is that usually with proprietary treatment devices, you've got a single point of maintenance and you can define it and the method of maintenance. So it's easy to define and put into your schedule. Whereas with vegetated, it's very often a diffuse maintenance. And some of the things that can be done, for example, like mowing grass, can actually make them block up more easily. So, you know, it's first glance you say, oh yeah, these innovative systems need to be maintained, but it's simpler, more obvious maintenance sometimes than vegetated systems. So you need to bear that in mind, I think, David.
Yeah, that's a good point, David. I mean, those are the sort of discussions we're having with our asset teams, is just trying to do that education really to sort of, well, I mean, as an LFA, that they're sort of resistant on vegetative treatments as well, because there's a lot of biodiversity issues that come into play as well when you're sort of maintaining some of the sort of greener systems, because you've obviously got to be very, very mindful of things that might be living there. So we're having all those sort of discussions at the moment, but yeah, certainly as designers, we are trying to promote those things as a whole treatment train. You know, we're not saying you necessarily have to go completely green. We're not saying you necessarily have to go completely proprietary. It is whatever is suitable for that individual site based upon the risks that you've got. So that's the approach we're taking. So I think one of the problems we have as an industry is we've sort of defined pipes and gully systems and then SuDS alongside. Really, it's an entire sustainable drainage system, whatever that might be.
Absolutely. Yeah.
So yeah. Okay. That's the challenge we're working with.
Yeah, we all are.
Thanks for sharing that. That's good to hear. So a technical question, which Dan, you may want to answer about the treatment flows in the code of practice are up to 11.3 millimeters per hour, but the how-to guide stipulates 27 millimeters per hour. Can the code of practice be directly applied for the tested connected area without a 27 millimeter per hour value? And Dan, I have memories of tables and
I can share the screen.
Number crunching in the appendix that we have been through multiple times. So hopefully you can help there.
The 11.3, there's no real difference between the 11.3 and the 27. I'll explain why. It is explained in the how-to guide. It will be best if I can just share my screen.
I remember these bits of the meeting. These where I went off and had a cup of tea because I didn't know what you were talking about.
So the is that coming through?
Yes.
Yeah.
The flow rates are derived from, or they are the centroids of the quartiles of volume of rain falling at different intensities in the UK. The graph's a bit easier to, so if you look at all of your rainfall volume falling over a given year, this is the typical distribution you get against your rainfall intensity. 27 millimeters an hour represents your annual peak. So you're designing your unit to accommodate that 27 millimeters an hour. It always has to accommodate that. But the test flow rates aren't carried out at the peak. They're carried out at the sort of the mid of the 0 to 25 and the mid of the 0 to 50 and the mid of the 0 to 75 and the mid of the 0 to the 75 to 100. So you're testing at a flow rate that represents that block of volume of rainfall falling in the year. And that's how you get back to a table that looks like this. So you've got 5 litres a second per hectare, 10 litres a second per hectare, 15 litres up to 75, but these are the percentiles. So you test at the 12.5 percentile, you test at the 37.5 percentile, you test at 87, but your unit design flow rate is based on that 75.
That makes sense, Sam. Do you want to unmute and tell us if you want to ask any more?
Can they unmute? Maybe.
Oh, I can try. Can you hear me?
Yes.
Yeah.
Okay, my question was just in terms of mitigation indices, because if you have 27 millimeters per hour and you're applying directly from the code of practice, what removal efficiency would this 27 millimeter hour get if it's kind of cumulative over a year?
So the treatment efficiency is related to the flow rate, but you would test one single device. So let's say I test a device that can do 75 liters a second, and that means I would test the device at these 4 flow rates. I would then add up the efficiencies that it got, the removal rates it got at those flow rates, and average them. And that gives you your average annual efficiency, which is what the mitigation index is representative of. So that's how you arrive at the removal rate. Now so I would have then assessed a unit that can do 75 liters a second with a given mitigation index. You then have to, but that's only testing one device. So you then have to map that to a larger or smaller unit size. And that is explained further down in the guide somewhere. So there is scaling. Here. So if you are scaling settling, you're aiming to maintain similar velocities within the system. So if you do twice the diameter, that gives you 4 times the area, and you can have 4 times the flow rate. So let's say your 75 liters a second unit was 1 meter in diameter. The next one up would, 2 meters in diameter would get you to 300 liters a second. Is that right? Yeah, that's right. Does that answer the question, Sam? You've got the efficiencies, but then you've got how you map the flow rate to different sizes of unit.
Yeah, I'm only confused because in the code of practice, it's a connected area to a device, and rainfall intensities are converted to flow rates. Those flow rates are tested, and you get an efficiency. So if you tested a device for, say, 500 meters squared, you wouldn't have a value for that 27 millimeters per hour under the how-to guide. So you would you have to then go up a size in your product range to match in the how-to? So a 500 meters squared tested device wouldn't be 500 meters squared in the how-to guide.
Yeah, they are. Sorry, Sam. Yeah, the test flow rates sit in those quartiles, in the middle of the quartiles, and those, once they're added together, represent a unit which is capable of doing 75 liters per second per hectare. So you've got that value there, which is then used in the how-to guide.
Okay.
Yeah, so if you said a drained area of 500 meters squared, is that what you're talking about? You wanted to derive a flow rate from 500 meters squared?
Yeah, I was just wondering if it's
So
500 meters squared, if it's directly transferable without having to figure out any other flow rates or.
Oh, if it can do, obviously, if it can do above the required treatment area or the drained area, then there's no issue. So if your device can do 700 square meters and you plug in 500, there's no concern. But if you plug in 700 to a device that can only do 500 square meters, then you've overloaded that system and you're not going to get your mitigation indices. I feel like we're confusing Sam more than answering the question.
Possibly.
It's those quartiles. It is really difficult to get your head around that if something's tested to 11.5 millimeters per hour, how do you know it still works at 27 millimeters per hour? And it is tricky to understand. And I know it's to do with pollutant load and mass loading of pollutant, but actually it is, if somebody's selling you something and says this can treat 75 liters per second and it will achieve mitigation index of 0.5, 0.7, 0.5, and then you do your calcs based on 7 millimeters per hour, and then you look back and go, well, this thing's only tested to 11.5 millimeters per hour. It does make it really complicated, but you just have to have faith, Sam, that graph and the quartile treatment, the quartile flow rates mean that that device will work for the whole rainfall distribution up to 27 millimeters per hour.
Okay, thank you.
Thanks everyone for chipping in there. Okay, I can't see any other questions in the chat. I've tried to check through, see if there's any hands up, which I can't see, but if I've missed any, and Hannah or Ma, you've seen any, please let me know, or anyone else wants to put a question in the chat, feel free to. So Dan asked or mentioned in his section of the presentation that possibly there might be a desire for further in-depth technical details, maybe working through one of the examples. Obviously, we've covered some of that with some of the questions here, but perhaps if I don't know that the chat's the best way to do that, but perhaps if you can pop something in the chat or pop an email. Mar, did you have there we go, a poll?
We have a poll, and in the poll is a question about a follow-up seminar, so it will be very helpful if we can
Perfect.
get responses.
So I'll leave that up there for a couple of minutes. If everyone can fill that in, that would be good. There's another comment there which is about LLFAs needing to understand the quartile testing scenario, which obviously we've touched on understanding from approving authorities earlier, and you know, the designer being the one to specify the appropriate treatment train and mitigation indices for the level of risk.
Yes, it might just be worth mentioning quickly that we've talked about the British Water website having that list of products that have had a test and then a mitigation, how-to guide conversion, and then verification of that how-to guide derivation. Timescales, do we think, how long do we think it might be before we start to see products manufacturers on that? I don't know, actually, if any, and I'm sure there's no manufacturers are going to tell us right here, right now, whether they've had their verification report, but will you update that monthly, Hannah, or if you start to get verification reports in?
As soon as we get sent them, they'll be uploaded to the website. So I'll put my email address in the chat, and people, if they have them already, feel free to start sending them to me. But British Water will send out a mailing maybe in a couple of weeks' time, just to remind people again to start sending them to us.
Okay, thank you.
Okay, can't see any other questions in the chat. Hopefully everyone's filled in the poll. Any other comments from any of our panel today, Joe, David, or Dan, before we finish up?
No, I just thank everyone for staying on. Actually, I see we managed to retain quite a number of people, so hopefully it's been useful for the people who've attended, and particularly thanks to Dan for taking on the role of trying to explain all this, which is very. The more you dive into it, the more complicated it is, and hopefully we've given a path for people to actually navigate through, from just getting percentage retention through to a mitigation index, which can be used by everybody.
David, I don't think people need congratulating for staying on for an hour and a quarter after the pain and suffering we've all been through, right?
Having to read the SuDS manual end to end.
Yes, at one point I could have done an example mitigation index conversion as well. Whether I can still do that, I'm not sure. Okay, well, thanks again, everyone. as I said, as has been alluded to, a lot of hard work went into the guide. Dan in particular, pulling together that information to make it hopefully consumable in a way that people could understand. So we'll maybe see you again on another session, and look forward to hearing any further feedback.